Types of polymerization reaction. The types of polymerization reaction having, the first one is the condensation polymerization reaction. Condensation polymerization reaction or chain growth polymerization reaction. The second one is addition polymerization reaction or step growth polymerization, chain growth polymerization reaction. This is addition polymerization is chain growth. This is step growth. Okay, the condensation is step growth polymerization reaction. Then copolymerization reaction, rubber will be there. Rubber copolymerization reaction. So these are the types of polymerization reaction. First we will see the addition polymerization reaction. What is the addition polymerization reaction? Means that molecules of the same monomer or different monomers add together on a large scale to form a polymer. That means the monomers used are unsaturated compounds like alkenes, alkadienes, so and their derivatives. So this mode of polymerization leading to an increase in the chain length or chain growth. Okay, that is either free radical also. This free radical also, or ionic species, whatever it is. This is called addition polymerization reaction mechanism. Okay, see here, here most common reaction, that is free radical mechanism. What is that free radical mechanism? Already you were studied in 11th standard free radical, where it is occurs in homolytic cleavage. Usually free radical obtained in homolytic cleavage. A reaction undergoes a homolytic cleavage. For example, in a single bond or carbon-carbon bond, oxygen-oxygen bond, whatever it is, just carbon-carbon, oxygen, whatever it is, just it undergoes a homolytic cleavage. This forms a radical, that is radical formation like this. The dot indicates radical. Okay, here the free radical mechanism involves three steps. That is three-step mechanism. The first step is chain initiation step. Chain initiation step. Second step, propagation step, chain propagation step. And third one is termination step. So this is the three-step mechanism. First, you must know for alkenes or alkadienes, the derivatives are polymerized in the presence of a free radical generating, that is initiator. Free radical generating initiator means that is nothing but initiator. You can write IN. IN also indicates initiator. So the initiator nothing but that is a catalyst. Look like a catalyst. Okay. Like benzyl peroxide or acetyl peroxide or tertiary butyl peroxide, any other one. The polymerization, for example, the polymerization of ethene. That means the polymerization of ethene to polyethylene consists of heating or exposing to light mixture of ethene with a small amount of benzoyl peroxide is the initiator. Okay, so this process starts with the addition, that is addition phenyl free radical formed by peroxide ethene double bond like this. See, that is the bond generating. For example, benzyl peroxide C6H5. This is chain initiation step, first step. Chain initiation step. C6H5, C double bond O, C double bond O, C6H5. So this is a benzyl peroxide. See the benzyl peroxide. Look, this exactly, this is in the middle. So the cleavage undergoes in this bond, that is oxygen oxygen bond undergoes a cleavage. So just look like this is a homolytic cleavage, so that formations of radical, so it forms, gives two phenyl, that is C double bond O and O. So one electron is shifted here, so that I am going to like this. Then the remaining what happened again, this undergoes further cleavage, means what happened, see, one bond is shifted here like this, so this shifted to this carbon and another one electron joined it together. So what happened, this will bond goes out for CO2, then it forms a phenyl radical, so that is 2C6H5. so this is a phenyl radical is formed. Okay, that is the process start with the addition of phenyl free radical formed with the peroxide to ethene double bond, thus generating a new larger free radical. That is, this step is called chain initiation step. That means you can add this, say 2,6C6H5 phenyl radical react with the addition of the double bond ethene, react with this to form a larger number. So to form a larger number of single bonds C6H5 and CH2 bond CH2 radical. Here addition of ethene, you can the molecule sizes increase. So the next step is called chain propagation step. Chain propagation step. So in this molecule react with one more alkene compound. See, C6H5 CH2 CH2 radical. Okay. Now again react with alkene CH2 double bond CH2. What happened? This is the propagating step. It's keeps on going, keeps on addition, so that keeps on adding ethene molecule, so molecule will be larger, so that C6H5 CH2 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 radical. Again addition of one more ethene, we will be getting like this. See, the chain goes like this, C6H5, the CH2 units join together, that is n time, because n number of that alkene molecules are joined together, it forms n number like this. So CH2 phenyl radical. So this is a chain propagation step. That means the repetition of this sequence with the new and bigger radicals carried the reaction forward and step is formed. This is called chain propagation step. Ultimately, at some stage, the product radical thus formed reacts with another radical to form a polymerized product, that is called chain terminating step. C6H5 CH2 CH2 chain then CH2 this and CH2 radical, then addition of one more this C6H5 CH2 and CH2 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 radical. This is a radical. Okay, this means the termination of long chain, these free radical can combine in different ways, that is to form a polyethylene. That is this is one of the way to form a polyethylene like this. See, the polyethylene compound like this, I will write here because the reaction is lengthy, the product is very lengthy. So C6H5 CH2 CH2 n times, here also n times, here also n times. Then again the CH2 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 then CH2 CH2. This is the repeating unit and C6H5. So this is the polymerization product. Okay. So this is the free radical mechanism. First, this is the chain termination step. Termination step. Okay, student. The free radical mechanism involves three steps. First is chain initiation. That is the first step. Then the initiator like benzyl peroxide, butyl peroxide, tertiary butyl peroxide, like this. This is the initiator, like I said, catalyst. Then chain propagation step. Then chain termination step. That chain termination step you will be getting product. Okay, student. The next is preparation of some important compounds, that is addition polymerization. This polyethylene. There are two types of polyethylene, that is, one is low density polyethylene, another one is high density polyethylene. First we will discuss the low density polyethylene. What are the low density polyethylene? Means that ethene under high pressure, that is 1000 to 2000 atmosphere, that is atmospheric, at temperature ranges 350 Kelvin to 570 Kelvin. The temperature ranges, that is the presence and the traces of dioxygen or a peroxide initiator, a catalyst, that is called low density polyethylene. So here the free radical addition and hydrogen bond abstraction highly branched structure. Okay, that is the low density polyethylene is chemically inert. They are chemically inert, then tough but flexible and poor conductor of the electricity. So hence it is used in insulation of electricity, that is in wire, electrical wire, then manufacturers of sequence bottle, that is toys and flexible pipes, like this. So these are called low density polyethylene. Then the polyethylene next is high density polyethylene. The high density polyethylene means that when addition polymerization, that is ethene, takes place in a hydrocarbon solvent in the presence of catalyst like triethyl aluminum, that is triethyl aluminum and titanium tetrachloride, triethyl aluminum and titanium tetrachloride. That is nothing but this is called Ziegler-Natta catalyst. The combination is called Ziegler-Natta catalyst. That is one of the name. Ziegler-Natta's catalyst means triethyl aluminum and titanium tetrachloride. This is called Ziegler-Natta catalyst. This at a temperature is like 333 Kelvin to 343 Kelvin. 333 to 343 Kelvin under high pressure. Pressure is 6 to 7 atmosphere. Look at here, 1000 to 2000 atmosphere, but here the atmosphere pressure is 6 to 7. The temperature is more or less, this is a high temperature, this is the moderate temperature. Okay, then this type is called high density polyethylene. That is, the linear molecule has a high density due to the close packing, because of the packing is very close. It is also this is also chemically inert and more tough and hard. That is, this is in manufacturers of example buckets like dustbins, bottles, pipes, etc. So these are called high density polyethylene. So polyethylene have two types, low density polyethylene and high density polyethylene. Then second one is the polytetrafluoroethane, that is called Teflon. Polytetrafluoroethane, that is called Teflon. How it is prepared? That is in the tetrafluoroethane. Tetrafluoroethane, that is CF2, double bond CF2, using of catalyst and high pressure. That is tetrafluoroethane with a free radical or persulfate catalyst. Can use persulfate catalyst. And a high pressure. So using of high pressure, it's chemically it's chemically what inert, that is, and resistant to attack corrosive reagent. So it is used in making oil seals like in two-wheelers, in engines, oil seals and gaskets, and also used in non-stick surface of coated utensils like this. So these are called Teflon. Using of this is called Teflon. Okay. Then polyacrylonite. polyacrylonitrile. Then the polyacrylonitrile means the addition polymerization of acrylonitrile, that is presence of peroxide catalyst, leads to formation of polyacrylonitrile. For example, NCH2 double bond CHCN. This is acrylonitrile. Acrylonitrile. The acrylonitrile undergoes a polymerization process using a peroxide catalyst. Peroxide catalyst, and it undergoes a polymerization process to form polyacrylonitrile. That is CH2CH bond CN. That is called polyacrylonitrile. This used as for wool in making commercial fibers or Harlan or Acrylene. So these are the uses of polyacrylonitrile. The next reaction is condensation polymerization or step growth polymerization reaction. We will discuss.